Alright, so here we are with Unit 5A, Lesson, I guess, 9. And we're going to be looking at something called empirical formulas versus molecular formulas. So let's get into that. The empirical formula is kind of, in a way, sort of a generic formula of a compound. It's the simplest ratio in which the atoms combine to form a compound. And I really do think it's probably the easiest way is just to show you examples. So if you look at the examples there, you notice that BaCl2, well, how is that? Do you know if that's an empirical or molecular formula? Well, it's ionic, so that's going to be its empirical formula. Ionic compounds, their formulas are all referred to as empirical formulas. If you look at number 2, that's not ionic. It is a molecular formula, but it also is already reduced. So that's actually both the empirical and the molecular formula. So if you take a look at the next one here at the bottom, in the middle here. Let's get the pen going here. Let's do color. Let's do green. See how that comes out. If you look at this compound here, C8H18. Here's the way you determine if it's empirical or molecular. Look at the subscripts and see if they are already in their lowest or simplest ratio. If you take a look at 8 and 18, you notice that they're both divisible by 2. If I divide both of these by 2, I'm going to get C4H9. This has now been reduced to its lowest ratio. The empirical formula, that would be its molecular formula. That's basically how you do empirical versus the molecular formula. So the empirical formula for C8H18 is C4H9. Now the molecular formula is the actual ratio of the atoms in a molecule. So if you look back at this, that's an actual existing molecule. That's an actual compound, C8H18. This compound does not exist. This is just a general ratio of how many carbons there are to hydrogens. This actually gives you the actual formula. If you take a look at the one at the bottom here, notice for some reason the pen is gone. Oh, hello. Here we go. If you look at this at the bottom, and you do the pen again, that's a molecular formula because that's a molecular compound. That's a sugar. But it can be reduced. Notice that all three of these subscripts are divisible by 6. So the empirical formula for this would be C1H2O1. That would be the empirical formula for this formula. Now, taking this one step further, let's say, for example, they wanted you to determine the empirical formula, and all that they gave you was, the percent composition. You could figure it out from that, and here's how you do it. So they say to you, well, we have a compound. It has 2 elements in it. It has hydrogen and oxygen. What we don't know is what are the subscripts. We're going to use these numbers to figure it out. So the first thing you're going to do is you're going to take these percentages and you're going to say, okay, I'm going to assume that I have a 100-gram sample because I can assume whatever sample size I want. 11.1% of that is going to be hydrogen, which means 11.1 grams are hydrogen. And 88.9 grams is going to be oxygen. Now what I'm going to do is I'm going to convert these numbers to moles. I'm going to take the 11.1 grams and I'm going to divide it by the mass of hydrogen from the table, which is 1.0 grams in a mole. Right? Grams cancel out and you're going to be left with, 11.1 moles. I'm going to do the same thing for the oxygen. I have 88.9 grams divided by the mass of oxygen, which is 16 grams in a mole. And let's see what we're going to have. I'm going to do 88.9 divided by 16 gives you 5.56. So it gives you 5.56. So right now what it's saying is that this number is 11.1 and this is 5.56. But you can't have subscripts as decimals. I can't have 0.1 of a hydrogen atom. I have to have whole number atoms. I can't have a tenth of an atom. So what you do then is you take both of the numbers in this case, the 11.1 and the 5.56, and divide them both by smaller of the two. I'm going to divide this by itself, 5.56, Obviously, that's going to give me 1. I'm going to do this same thing here, 5.56. That's going to give me 2. So what that's saying is that my subscripts are 2 for the H and 1 for the oxygen. So my formula is H2O. There is a way of checking to make sure this is correct. If you did the percentage composition of this like we did in the previous lesson, these are the numbers that you would get. And that's how you do it. Let's do another one. So we have here, we have another compound that, I guess the green is alright. First step that we're going to do is we're going to change these to grams, and I'm not going to bother going through that. I'm just going to take this and divide it by its mass from the table, which is 137. I'm going to do this same thing. I'm going to divide this by the mass of carbon, which is 12, and this, which is oxygen, which is 16. So what do I get when I divide this? Well, this one I get 0.51. I get the same thing here, 0.51. And in this one, I get 1.52. So what it's saying so far is I have barium's Ba is 0.51. Carbon is 0.51, there's a decimal here, and the oxygen is 1.52. But of course I can't have these numbers. So again, I go back and I divide, in this case, all three by the smallest one. And that's 0.51 is 1. 0.51 divided by 0.51 is 1. So I know that barium is a 1, carbon is a 1. And I do the same thing here, 0.51. And that's going to come out to approximately 3. So I know the oxygen is 3. And that's the formula using these empirical formulas. I mean, using these percentages. So you can do that last one as another example. And again, make sure this is all completed. And that's it for this lesson.